All right, guys. So in this video, we're going to talk about um, the Lewis structure of water, and then we're going to move to more complex structures. I'm going to post a link in the description with the video that it's going to talk about like stuff like phosphorus, pentachloride, etc. So more complex structures. But the basic principles that I apply here should be applicable to most of the molecules you guys will see in your general chemistry classes. So let's talk about the steps that I usually take with getting the Lewis structure of any particular molecule. In this case, we're going to look at a simple case of water, right? So I write out my molecular formula. So water, I know, is H2O. And then I simply say, okay, well, how many atoms do I have, right? I have 2 hydrogen atoms and I have 1 oxygen atom, right? So in total, I have 3. In total, I have 3 atoms, right? And so I have that laid out. And so now I need to look at, okay, well, where is my valence electrons? Like, how many valence electrons do I have? Well, I do not have the periodic table in front of me, but what you guys should know is that once you listen carefully, everything in the column 1, which is 1A on the periodic table, including hydrogen, lithium, sodium going down, those have 1 valence electron. The next group over, starting with beryllium, has 2 valence electrons. We're going to skip the transition metals and we're going to go to boron, and everything in that column, boron, aluminum, etc., has 3 valence electrons. So you can see the pattern. So going all the way to oxygen, we're going to have 6 valence electrons. So I want you to count. So from hydrogen going to beryllium, so that's 1, that's 2. And then we go to boron, that's 3. We go to carbon, that's 4. We go to 5, that's nitrogen. We go to 6, that's oxygen. We go to 7, that's fluorine. And we go to 8, which starts with helium. And those are actually noble gases, right? So if you count the columns, not including transition metals, from left to right, with hydrogen being number 1, then the next column over would be 2. And then you skip the transition metal with boron being number 3. And remember, it's not just the first atom, it's everything within that column. So going to oxygen and sulfur, which is oxygen's cousin, right? Those have 6 valence electrons. And so oxygen has 6 valence electrons. Hydrogen, on the other hand, it's in the first column, so it has 1 valence electrons, right? So the next thing, so now that we have identified our valence electrons, right? Now that we've identified our valence electrons, right, I add them up. Now remember, 6 times 1, right, I have 6 electrons from oxygen, but I only have 1 oxygen, so that's just 6 electrons. And then I have 1 electron from hydrogen, but remember, we have 2 hydrogens, so it's 2 times 1, which will give me a total of, this will give me a total of, right, this will give me a total of 8 electrons. Right, so I have a total of 8 electrons to put within the molecule. Now remember, usually, and I say this usually because it's not always the case, and you're going to see, but usually when we write Lewis structures, we need a central atom, right? And the central atom is usually the first atom in the molecular formula. However, oxygen, H2O was a little bit of exception, right? Because hydrogen could only form 1 bond. And so in this case, we have to put the oxygen in the middle, right? And so if we put the oxygen in the middle, we can kind of fill in our hydrogens. And then the most simplest thing with most molecules, there has to be at least a single bond, right? And so if I put a single bond within these 2 right here, right? Then how many electrons we've used up out of the valence electrons thus far? We've only used up 4, right? Because remember, a single bond consists of 2 electrons. So in this case, it's 1 from the oxygen and 1 from the hydrogen. Remember, hydrogen only has 1 valence electron, so there's 1 valence electron. And then on this side, again, we only have 1 from the oxygen, 1 from the hydrogen. So we've used 4 electrons thus far. We've only used 4 electrons thus far. Now remember, oxygen, nitrogen, fluorine, right? Those are atoms that have to satisfy the valence, have to satisfy the octet rule. And the octet rule says that in the molecular formula, 8 electrons should be around the central atom, or any atom, doesn't have to be the central atom, but any atom to get its least, to get its most stable form. So less energy, right? Nature favors stuff with the least energy. And so if that's the case, we've seen that we really only have 4 electrons thus far around oxygen, right? We have 2, and then we have 4 from the other double bond. So where are we going to put the other 4 electrons that are missing? Because remember, we have a total of 8, right? Now, can we put it around hydrogen? No, we can't do that, right? Hydrogen can only form one bond. It only has one valence electron. And remember, hydrogen is one of the exception, along with boron, and where it does not fit the octet rule. So right, it's less than 8. It's usually less than eight electrons. You have atoms like sulfur and phosphorus that have expanded octets, and you guys will see. And so those will kind of expand um, beyond the octet rule, which is totally fine. All right, so in this case, we only have one option, and that is to put or valence of the remaining 4 electrons, right, around the central atom, right? And so now let's count the total number of electrons like we added up here and see if that's what we have, right? So we have 2, 4, 6, 8, right? And there's our Lewis structure. Now remember, right? So there's our Lewis structure, right? So now remember, a quick thing you could do in an exam per se is that if you've counted the total number of electrons to be 8 and somehow you get, like, say for example 7 or 6 or something, then you know you've done something wrong, right? So that's the end of the video, and we'll talk about more complex structures in the next one.